Hello everyone, we're here today to talk about Math 120, section 6.2, and this deals with formulas. So first let's define what is a formula. A formula is an equation that has a repeated application. Formulas are equations that we can use repeatedly, that have applications that appear more often than one-time uses, right? Evaluating a formula, well, to evaluate a formula, we plug in the known values and use equation solving techniques. To find the unknown value. When dealing with formulas, you'll plug in the known values and use equation solving techniques to find the unknown value. If an equation has, let's say, multiple variables in it, you'll plug in all the variables you know, but there'll be one you don't. There'll be one you are trying to find, one you are trying to evaluate, right? That's what a formula is there for. So let's take a look at some real-world formulas. The first is a simple interest formula. And the formula for simple interest is I equals P times R times T. Now, it would help to know what each of these letters stands for. Well, I is for the interest. We use I to represent the interest. That's how much money you have earned in interest. P is the principal. It's how much you started with, the principal amount you started with in an investment. Maybe you go to the bank and you take out a loan. How much the loan was for. Maybe you deposit money. How much the deposit is for. That's the principal. It's the starting amount. The principal is the starting amount. R is the rate. The interest rate, right? Now, it's important to know that you need it as a decimal. The rate will be given as a percent, but we need to calculate it using a decimal form. So you'll have to translate from percent to decimal. And we'll take a look at that in just a moment. And then T is the time. How long was the loan or the deposit for? What time has it passed? So let's look at a potential real-world example. Let's say you want to know how much interest has been accrued on a 5-year loan of $3,000 with a 4% interest rate, a 4% rate. So how much interest has been accrued? I actually think accrued has two C's. How much interest has been accrued or earned or accumulated on a 5-year loan of $3,000 with a 4% rate? Well, here's where we want to figure out which we know and which we don't know. 5 years, that's the known, right? So my time is 5. Time is the value 5. The rate, it says a 4% rate. I don't plug it in as 4% though. I plug it in as 0.04, right? That's the same decimal. 4%, to go from percentages to decimals, you divide by 100. That's where we get 0.04, right? We have to divide by 100. So I need to use 0.04 for the rate. You have to use decimal form. The principal, how much was the loan for? Well, $3,000. And the interest was my unknown, right? There'll always be a variable you don't know. So we set up our equation. I equals P is 3,000. The rate is 0.04, and the time is 5. Now, to get the interest, all we need to do is multiply. 3,000 times 0.04 times 5 gives me 600. So my answer would be $600 because it's interest, right? It's money. So how much would I have to pay the bank back if I got this loan? I would have to pay back $3,000 plus the $600 interest, right? If I wanted to pay off my loan, I have to pay the interest as well as how much I borrowed. That's how interest works, right? So there is our first example, simple interest. Our second example is volume of an ice cream box. So let's draw an ice cream box. You know, it's shaped like a box, right? So maybe we have, a front side. Maybe it's a little shallow in depth. We'll draw a nice 3D picture. And to get that perspective, you would be able to see that edge coming down into the box, right? So here's a box. You can put ice cream in it, right? Maybe your favorite brand. Since we're in the North Country here, I'm going to put Stewart's on it. Stewart's has ice cream. And we want to talk about the volume. Well, the equation here is volume is equal to length times width times height. Volume is equal to length times width times height. If you want to write out like we did here, feel free to, but this being a more general formula we see more frequently, we've probably all seen a volume of a box formula, right? We know that boxes have volume. We know they have a length, a width, and a height, right? Well, how would we calculate the volume of an ice cream box? Let's say that it is, maybe 20 centimeters by 14 centimeters by maybe the height is 12 centimeters. So 20 centimeters by 12 centimeters by 14 centimeters, right? It's got a length, a width, and a height. So my volume would be equal to the length, it's 20 long, times the width, it's 14 wide, times the height, it's 12 tall. So volume is equal to, well, we just need to multiply, right? 20 times 14 times 12 is equal to 3,360. 3,360. Now the units. I had centimeters, centimeters, and centimeters. However, a box is a 3D object, right? It's a three-dimensional object. It has a length, a width, and a height. I have centimeters cubed because it's a three-dimensional object. It takes up 3D space, right? Think of the centimeters times centimeters times centimeters would give you centimeters cubed, right? Volume is a third power unit. It's a three-dimensional unit. It takes up three-dimensional space, right? Just like when you're talking about floors, when you're talking about a rug, it's square footage, right? How many square feet is a rug? Because a rug takes up two-dimensional space, right? So there is a geometric formula. Now, we're going to talk about a statistics formula. Some of you may go on to take statistics. You might see this formula in statistics. Now, this formula is Z equals X minus the Greek letter mu, mu, which looks like a U with a vertical line on it, over the Greek letter sigma, which is over itself the square root of the letter N. So this Greek letter is sigma. Now, this statistics formula is used when calculating things that have to do with data sets. And here, let's talk about what things mean. Let's define the variables at play. Z is what's called the z-score. Now, we actually don't need to know what a z-score is to use the formula. And that's why we're using this formula, because even though we might not know what the variables themselves actually mean, we can still evaluate formulas. We don't have to understand the real-world application to do the mathematics behind it, right? X is my data value. Mu, well, mu is the mean. It's the average. In statistics, you can talk about the average, right? Sigma is what's called the standard deviation. I'm going to write standard dev. That is just another statistical measure. It tells you how spread out the data is. It tells you whether the data is spread out or really concentrated around one value. We'll actually be calculating means and standard deviations later in our course, but for right now, we just need to know they exist for this formula. And then we're missing one letter. What's n? N is the sample size. So n is how many people you're looking at. Now, this formula can be given to us, and the values can be given, and we can calculate it without having to know the true meaning behind all the statistics, right? Let's take a look at that. Let's say that my data value in question is 100. My mean is 84. My standard deviation is 20, and my sample size is 25. So what this is saying is I have these values and I want to calculate my z-score. The question has given me the values of the different variables. It didn't give me any setup. Where does this data come from? What is the average talking about? What is the mean talking about? It doesn't matter in calculating the formula. I don't actually need to know the application to use the formula. We just have to plug in. Well, z is equal to, let's see, x is 100 minus 84 over sigma is 20 over the square root of 25. Now, whenever we see a large fraction like this, we want to think about the top as its own problem. 100 minus 84. That's going to give me 16 in the top. And I want to treat the bottom as its own portion. 20 over the square root of 25. Hey, the square root of 25, that works out nicely, doesn't it? Maybe I forgot, but remember square root of 25 is 5. So in the bottom, I'll get 20 over 5. Now, my top portion, I figured out, right? The bottom portion, I still have to do the division, right? In the bottom, I still need to divide. Well, I have 16 in the top. 20 divided by 5 in the bottom gives me 4, right? 5 goes into 24 times. So I worked the top and bottom separately, and now I'm ready to deal with the big fraction bar. Remember, you need a single number in the top and the bottom before you can deal with a big fraction bar, right? You keep the top and bottom separately. Well, 16 divided by 4 is 4. Now, you might ask yourself what units go here. There were no units given on any of the data because we didn't know where it came from, right? The units can't be applied here because I don't know where the data comes from. And if we actually knew, z-scores never have units. That's just part of what a z-score is. It doesn't have a unit. So 4 is our answer. We won't put a unit on it. However, in interest, that was money. We put a unit on it. Volume, that's taking up space. We put a unit on it. A statistics formula here, the one we used for z-score, we didn't put units on it. So as we can see, formulas can come from things we understand for financial reasons, geometric reasons, or from situations we may not be aware of, but we can still mathematically solve. We might not be aware of what the true meaning behind this formula is, but we can still plug the values in and solve the equation, right? And that's 3 different examples. So a lot of times with formulas, you'll be given the formula, right? Because you'll need to know what formulas to use. So, we have one more thing we want to talk about. Solving for a variable in a formula or equation. Well, a formula is said to be solved for a variable if that variable is isolated. So a formula is said to be solved for a variable if that variable is isolated, if it's alone. We can use techniques of equation solving to do this. The techniques we've learned about equation solving allow us to do this. Before we do, let's look at the formulas we already had. Interest is solved for I. It's solved for the interest. It's not solved for the principal, the rate, or the time. Volume is solved for volume. The statistics formula is solved for z, because those are the variables that are by themselves. When I look at this equation, it is not solved for any of the letters. None of the letters are isolated. But it wants me to isolate the letter y. So I'm going to copy the equation down. 2x minus 5y minus 10 equals 0. Now, there's nothing on this side of the equation, right? It's just 0. And I need to get y by itself. There's a lot going on this side, so I'm going to bring the y over here. I'm going to try and get the y term by itself. I have minus 5y on the left, which means I need to add 5y to cancel it out on this side, right? Minus 5y, the opposite would be plus 5y. If I do it to one side, I have to do the same thing to the other. So I'll add 0 plus 5y. Over here, this will cancel and leave 2x minus 10 equals 0 plus anything gives you back that same thing, right? 0 plus 10 is 10. 0 plus 100 is 100. 0 plus 5y is just 5y, right? Adding something to 0 doesn't change what you started with, right? You still keep 5y. Now, the y is getting close to being by itself. I only have this 5 here. This is 5 times y, right? What is the opposite of times? It's divide, right? So if I want to get rid of this 5, I need to divide by 5. However, the division rule says I need to divide everything by 5. So I'll divide this by 5 and this by 5. The division rule, you have to divide everything by 5 if you want to cancel out this 5. So that'll cancel that out, which will leave me with y equals. Notice I moved it to the left side. It doesn't matter, right? Left and right are just arbitrary choices for which it is. I want the y on the left just because it looks nicer. 2 divided by 5. I don't know. 2 divided by 5 doesn't simplify, right? So I'll leave 2 over 5. And that has an x, right? Minus 10 divided by 5. I know 10 divided by 5 is 2. So now, the equation 2x minus 5y minus 10 has been rearranged to become the equation y equals 2/5 x minus 2. These equations tell us the exact same thing. The only difference is this is now solved for y, which is a useful thing for us because sometimes getting your equation in a certain format will be beneficial for us algebraically. It'll allow us to more easily look at it. If you ever graphed equations, this is in point-slope form. This is an easy equation to graph on graph paper. This, not so much. So keep that in mind. Now, let's look at a new statistics formula. Notice it's pretty similar. There's just not that extra square root of n in the bottom, but that's okay. It says solve this formula, z equals x minus mu over sigma. This is a different z-score formula, which if you take statistics, you'll learn about the difference between these two formulas, why you use one or the other, for x. So x is right here. So let's take a look. Z equals x minus mu over sigma. So I need to ask myself, how can I get x by itself? Well, I've got this big division bar here I need to sort out. What's the opposite of dividing by sigma? The opposite of dividing by sigma would be multiplying by sigma, right? Instead of dividing by sigma, I would want to multiply by sigma. But remember the golden rule of equations. If you do it to one side, you need to do the same thing to the other side. So I'll multiply both sides by sigma, because on the right side, it'll cancel out and leave me with x minus mu. And on the left side, sigma times z, I don't know what sigma times z is, so I'll just leave it as sigma times z, right? I don't need to write the multiplication symbol because when two variables are next to each other with no operation between, it's assumed to be times, right? Now, the x is getting close to being by itself. I just have to take care of this minus mu portion. What's the opposite of subtracting mu? The opposite would be adding mu. So I want to add mu. Remember, if you do it to the right side, though, you have to do the same thing to the left side. Plus mu. So I have x alone here equals sigma times z plus mu. Are these like terms? No, they have none of the same letters, right? These are not like terms. I cannot combine them. So I'll just write sigma z plus mu. I can't add these two together, so I'll leave them as separate terms. And this formula is now solved for x, right? We could have circled this one too. We have isolated x as our variable of interest, right? And this formula is actually used in statistics too. We use this formula in statistics as well. And we use formulas like this as well. We'll see this later in our course. We'll be doing some graphing. Now, I said slope-intercept formula earlier, y equals mx plus b, and we want to solve it for m. So let's write y equals mx plus b. Well, the first thing I notice is I've got a plus b I need to take care of, right? I need to subtract b from both sides. Subtract b from both sides. Well, on the right-hand side, that'll give me mx. And on the left-hand side, y minus b are not like terms, so I'll just leave it y minus b. Now, I'm almost done. The x is almost, the m is almost alone, right? I just need to get this x out of the way. The operation between m and x is multiplication, so the opposite of multiply is divide, so I'll have to divide by x on both sides. If I divide by x, I need to divide everything by x. Just like here, when we divided by 5, we divided everything by 5. Now remember, you can divide everything by either putting, double division signs or a single division sign. Here, I divided both individually because they were numeric. I knew I would be able to divide 10 by 5, right? I knew I could simplify it. I don't know what y divided by x or b divided by x, so I'll just use one big fraction bar. Here it will cancel out. I'll be left with y minus b over x equals m, which is now solved for m. Notice this time I just kept the m on the right. It's arbitrary, right? It doesn't matter which side is left or right because it's an equal sign. Both sides are equal, right? So you could have, mirrored it over, put m, so m on the left equals y minus b over x on the right. And now we have solved these three equations for the requested variable. Notice I used the same techniques we've been using for equation solving. You can subtract things from both sides, you can multiply both sides, you can divide both sides. These are all the tricks we've already been using. The only difference now is the values are less numeric in nature. We have more variables at play. We're working with formulas that have multiple variables in them. And that's an important real-world application of mathematics to be able to manipulate your formulas. And that brings us to the end of section 6.2. Thank you for stopping in, and I will see you next time.